AI agents are absolutely taking the world by storm. I mean, they can use tools, they can write code, they can solve problems all on their own. It's a huge leap forward. But these incredibly powerful new minds have a hidden and pretty critical weakness.
And that weakness? It's their own memory. You see, the more an agent does, the more it has to remember. And the more it remembers, the more cluttered its memory gets. It's like a bottleneck that can grind even the smartest AI to a complete halt. So how do we fix this? How do we build an agent that has a sharp memory that doesn't get bogged down?
All right, so here's what we're going to cover. First, we'll dive into the core problem, which is known as the agent's paradox. Then, we'll look at the solution, a new field called context engineering. We'll break down the core strategies, hear some lessons straight from the field, and then wrap up with a really surprising insight about the power of keeping things simple.
So what is this paradox exactly? Well, it really all comes down to the absolutely breakneck speed of progress. I mean, in just the last couple of years, we've shot from crafting simple prompts to having agents that can tackle these incredibly complex problems.
Just think about it for a second. In late 2022, the big thing was prompt engineering, figuring out the perfect way to ask a chatbot a question. Barely 6 months later, we were already in the year of agents, which suddenly required this entirely new skill, context engineering. The pace is just staggering.
So here's where the trouble really starts. A single, pretty typical task for an agent might involve over 50 tool calls. We're talking searching the web, running code, accessing files, you name it. And every single one of those actions gets added to the agent's memory or its context. For really complex jobs, this creates this massive, ever-growing history that the agent has to lug around with it.
And right here, this is the paradox. To do its job, an agent needs more tools and more context. But all the research shows that as that context window gets bigger and bigger, the model's performance actually gets worse. It's a phenomenon they're calling context rot. This is exactly why an agent that's supposed to book a flight might start off great, but after dozens of steps, it gets so lost in the details that it ends up trying to order a pizza. The very thing it needs to be powerful is also the thing that's holding it back.
Okay, so how in the world do we solve this paradox? Well, the answer lies in a brand new discipline that's all about managing the agent's memory with absolute precision and focus.
And this is what we call context engineering. The goal here isn't to just cram as much data as possible into the model's memory. No. Instead, it's the art of carefully curating that memory, making sure the agent has exactly the right information for its very next step and absolutely nothing more.
So, how does this actually work in practice? Well, let's open up the engineer's toolkit and take a look at the core strategies that people are using right now.
It turns out across the entire industry, 5 main strategies have really started to emerge. First up is offloading. You can think of this like putting a file away in a cabinet instead of keeping it on your desk. Then there's reducing. This is like writing a quick 1-paragraph summary of a super long report. Third is retrieving. That's only pulling that file out of the cabinet when you absolutely need it. Fourth, we have isolating. So instead of one person trying to do everything, you have a whole team of specialists, and each one has their own focused set of notes. And finally, there's caching, which is really just a clever way to remember recent results so you don't have to do the same work over and over again.
And listen, these are not just theories on a whiteboard. The biggest names out there in the agent space, from Manus to projects by Anthropic and Cognition, they're all using combinations of these exact strategies. This has pretty much become the new standard for building agents that actually perform well.
Okay, now let's get even more practical. Let's look at some hard-won lessons from the team over at Manus, who are in the trenches building these agents in production every single day.
Now, what's really wild about this space is the speed. This quote from Peak, the co-founder of Manus, it just says it all. July is basically the last century. I mean, think about that. What they learned just a few months ago might already be totally outdated. And that's exactly why these fresh, battle-tested insights are so incredibly valuable.
So, one of the crucial lessons is knowing the difference between your reduction techniques. You've got compaction, which is reversible. Think of it like saving a bookmark to a website instead of saving the entire web page. You don't have the content right there, but you can always get it back perfectly. Then you have summarization, and this one is irreversible. You're creating a shorter version, which means details are going to be lost forever. It's super powerful, but you have to be really careful with it.
The Manus team also figured out this really clever way to offload the agent's tools, not just its data. Think of it like a workshop. On that first layer, you've got your simple hand tools right there on the bench, things like reading or writing a file.
On the next layer, you've got your power tools, but they're in a secure sandbox, more powerful but still controlled. And then on the highest level, the agent can actually go to a whole separate workshop, writing its own Python scripts to use heavy machinery or external APIs. This layered approach gives the agent these huge capabilities without cluttering up its main workspace.
But after all of this complex engineering, the single most powerful insight is surprisingly incredibly simple, and maybe even a little bit counterintuitive.
This right here is the key takeaway. After months and months of building, the Manus team found that their biggest breakthroughs didn't come from adding more clever hacks or more complex layers. They came from simplifying, from stripping away unnecessary tricks and just trusting the model a little more to do its job. The goal isn't to build some complicated scaffold around the model. It's just to make the model's job simpler.
And that really leaves us with a final thought to chew on. Are we actually building smarter agents? Or are we just building more and more elaborate scaffolding? Because as these models get more and more powerful, the next big breakthrough might not come from adding more complexity, but from having the courage to take it away.